Okay, in this question I'm going to show you how you can solve simultaneous equations by graphical means. So we're going to start with our first equation, which is y equals 3x plus 1. And we have to just remember how we graph that. So the first thing we know is that because it's in the form y equals mx plus b, that means that 1 is our y-intercept, is 1, and our gradient is 3. So when we graph that, which we're going to do over here, okay, so on this graph we're going to start with our y-intercept, which is 1. So just here. And then we have a gradient of 3. So our gradient of 3 means we go up 1, 2, 3 and across 1. Again up 1, 2, 3 and across 1. Okay, so our line should be going through those 3 points. So let's go ahead and draw that. Okay, there's our first line. We're going to do the same for the second line. Our second line has equation x plus y equals negative 3. So if I rearrange that, I get y equals negative x minus 3. So all I've done is subtract the x from both sides. Okay, that then lets me determine the y-intercept, which is negative 3, and the gradient, which is negative 1. So a y-intercept of negative 3 is here, and a gradient of negative 1 means that for every 1 I go down, I go across 1. 1 down, across 1, 1 down, across 1, and so on. Alright, so my line needs to go through those points. And just change the colour so you can see which line's which. Alright, so there I've got my 2 lines, and you can see that they cross at one point in particular, this point here. Alright, now that point there has coordinates negative 1 and negative 2. Alright, so that's the point where they meet. So that solution works for both of those lines. Alright, now you can double check that. If I want to check with the first equation, I put negative 1 in place of x, because that's what my coordinate said. So this is the point that I'm checking. So I have y equals 3 times negative 1 plus 1. So y equals 3 times negative 1 is negative 3, plus 1 is negative 2. That's the y coordinate, so I know that that's right. In the second equation, if I let x equal negative 1, I get negative 1 plus y equals negative 3. When I add 1 to both sides to get y on its own, I get negative 2. And again, that fits my coordinates from above. So I know that I've got the right solution. Okay, so just to summarize that again, to determine the solution of simultaneous equations, we can do it graphically. We just need to first of all sketch each individual line. It needs to be drawn to scale so that we get an accurate answer. So once we do that, we draw up the 2 lines, find the point where they cross, and that is the solution of our simultaneous equation. So our final solution would be x equals negative 1 and y equals negative 2. That's it.